Hello everyone, I am going to show you how to construct a day-night street lamp controller. So first I will draw the schematic diagram of the day-night street lamp controller. This circuit is based on 741 operational amplifier. This 741 operational amplifier has 8 pins starting from pin number 1 to pin number 8. So pin number 4 is the ground wire and pin number 8, 1 and 5 are not used in this case. So pin number 7 is connected to the plus line. So in this demonstration I am going to use a 9 volt battery as the power supply. The output pin of this operational amplifier is connected to a LED via 1 kilo ohm resistor. So this 1 kilo ohm resistor is used to limit the current through this LED. The pin number 2 is connected to a variable resistor, which is actually act as a potential divider. Using this potential divider you can obtain any voltage level between 9 and 0 at pin number 2. The value of this variable resistor or the preset is 33 kilo ohms. Then the pin number 3 is the sensing pin. Again we are going to use a potential divider, 4.7 kilo ohm resistor, and the LDR or light dependent resistor is the sensing element, which is connected to pin number 3 and the ground through a 1 kilo ohm resistor. This resistor is actually not necessary, but as a protecting device it has been used. So this circuit is completed. Now we are going to implement the circuit according to this schematic diagram. Okay, now I am going to build the circuit according to the schematic diagram given here, and these are the components we need. So we need a small Vero board to mount components. In this case I have used a dot board, and to mount the 741 IC I am using this IC base. In a case of 741 failure, we can easily remove the 741 from the Vero board, and here we need some resistors, 1 kilo ohm resistors and 4.7 kilo ohm resistor. Then to adjust the sensitivity, we are going to use this variable resistor 33 kilo ohm preset, and the sensing element is a light dependent resistor LDR. Here you can see the LDR, and the output is a LED. Here I am going to use a normal size red color LED. To power up the device, I am going to use this 9-volt battery, and this connector will be used to fix the battery to the circuit, and continuously this should not be connected to the battery because battery may derate. Therefore I am going to use on-off toggle switch for this demonstration purpose, and we will start constructing the circuit. So you have to have basic tools like soldering iron and lead, tweezer, paper cutter, and some circuit wires are required. Then first we will mount this IC base on the board. Make sure whether all the pins are soldered to the circuit board properly. Then we will start from the output side. First we'll connect the LED, and since there is a resistor in series, I have to solder the resistor first. It is soldered to pin number 6. So you don't need to worry about the polarity of a resistor. There is no such polarity. Usually resistors have long leads, so this can be removed. Then next I am going to solder the light emitting diode. again you can remove these long pins. So we have completed with the output side, and next I am going to connect this variable resistor. So be careful when you mount this variable resistor. Leave a significant space between the variable resistor and the IC base, because later you want to plug this IC and remove, though it is not frequently. When you leave a space like this, you can easily remove the IC from the board without damaging the variable resistor. Now we have finished with several components. Next we are going to mount the sensing part of this circuit. So I am going to place the light sensitive resistor here. Depending on your requirement, you may have long cables to this LDR if you want to place this LDR at a separate location. So it's up to you. And then this protection resistor can be soldered. if some pins are not long enough, you can use these additional wires to extend those pins. Or sometimes removed pins from some resistors like this one, so sometimes you cut it since they are too long, then you can use this removed part to extend these pins. Sometimes they can be used as jumpers as well. To remove the insulator of this type of circuit wires, you can use this paper cutter. number 7 is the positive power supply pin. I am going to solder it to this 4.7 kilo ohm resistor, which is the upper part of the sensing potential divider. There's remaining one pin, the top pin of 33 kilo ohm variable resistor. So I have to connect it to the plus voltage line. So we have completed the circuit, and now we want to have external cables to supply the 9 volt, then so I'm going to use this 9 volt power supply connector with this turn on and turn off switch. Usually we connect the turn on and off switch to the plus terminal of the battery. Either you can use this on off switch with the plus terminal or minus terminal. In this case I am going to connect it to the plus terminal of the battery. So we have almost completed the circuit, and at the end of implementing the circuit, just double check whether you have soldered everything properly with your designed schematic diagram. So if there is any different, you can change the wirings or solderings. Now I am going to mount this 741 operational amplifier. And I will connect this battery to the circuit. So this is the completed circuit, and now I am going to test this circuit. So first make sure to turn on the device, then this battery will provide the power to this integrated circuit and the circuit components. And next, take a screwdriver and adjust this variable resistor. So when you rotate clockwise direction, this LED will turn on, and when you rotate anti-clockwise direction completely, it will turn off. So that indicate there is a threshold point between those extreme limits. So I will gradually rotate towards the center where I can find the threshold point of this variable resistor. So this is the threshold point. If I slightly move the preset anti-clockwise direction, it will turn off, and if I turn clockwise direction, it will on. So since the lighting condition here is high, this LED should be at off condition. Okay, now the LED is off condition. If you cover the light dependent resistor, you can see that this LED will turn on. So when I cover the this LDR by my finger, then this will turn on. So instead of covering this by hand, I am going to turn off the light in this room. So now you can see the LED is turn on position. So if I turn on these lights back, so you can see the light is going back to its off position again. So this is a simple day-night street lamp controller. So as you know, this LED cannot light your room. Therefore, instead of using this LED, you can connect a relay to drive a high power filament lamp or any other lamp. So if you connect a relay to the output of this 741 operational amplifier, make sure not to connect directly. Use a drive transistor and connect a protection diode in parallel to the relay to prevent the high damaging current when you turn on and off the transistor. So that's it, and if you have any question, you can post on this wall and I can reply you as soon as possible. So thank you for watching this video.